Today we're talking about probably my favorite topic in geometry, which is trigonometry. So you're going to take this and fold it over to this point, and then you can cut these flaps after we're done. The three main trigonometric functions are sine, cosine, and tangent. Each one has a specific relationship with certain sides and angles of triangles. So sine is the ratio of the opposite side over the hypotenuse. So if these were angles A, B, and C, the sine of angle A would be the ratio of the side that is across or opposite angle A over the hypotenuse, which is of course the side that's opposite the right angle. So opposite over hypotenuse. That is this side and this side. We have the same triangle here with angles A, B, and C. The cosine of angle A would equal the ratio of the length of the adjacent side over the length of the hypotenuse. So the adjacent side is the side that's next to angle A that isn't the hypotenuse, and then the hypotenuse is the other side. So the length of this side over this side is the cosine of A. And then finally, tangent for the same triangle A, B, C. The tangent of angle A is equal to the ratio of the length of the opposite side over the adjacent side. So again, the opposite side is the side that's across from the angle, and the adjacent side is the side that's next to the angle that's not the hypotenuse. So this side over that side would be the tangent. And we have a way to remember this, which is SOHCAHTOA, right here. Sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. Now let's open up our first flap and do some practicing with sine. So first, to find the sine of an angle, as I said, sine is the length of the opposite side over the length of the hypotenuse. So the sine of angle A would be the length of the opposite side, which is 6, over the length of the hypotenuse, which is 10. And then we can simplify that fraction. If it's not simplified, remember you can do this in the calculator, but in this case it would be 3/5. So the sine of A is 3/5. The sine of B is the opposite side from B, which is 8, over the hypotenuse, which is still 10. So that simplifies to 4/5. So the sine of angle B is 4/5 for this triangle. Now we can also use trigonometric functions to find the lengths of sides that are missing. So this one is to find BC and AC using only the fact that we know this is a 21-degree angle and that the hypotenuse is 9. So we're going to use the calculator to do this, but it's very important that you check the calculator before you start because there are two ways to measure the angles of triangles. One way is degrees, and that's the way that we're always using in geometry for now until we learn the other way. And the other way is in radians. So you got to look up at the top of the calculator and see, is this in degrees or in radians? This was in radians. So we're going to go to the mode, which is this button right here, and tell it that we want to switch to degrees. And then quit. So now we're in degrees. So now it will work and give me the correct answers. So now first I got to look at what I know about this triangle. I know that side AC is opposite this angle that I know. So the sine of 21 degrees, which is the measure of this angle, is equal to the length of the opposite side, which I don't know, but I want to find out, over the length of the hypotenuse, which is 9. Now to solve this for x, all I have to do is multiply both sides by 9, because x divided by 9, since it's division, I'm going to multiply to undo it. So that cancels out, and then I multiply this side by 9. So x, or the length of this side, is 9 times the sine of 21 degrees. So in my calculator, I'm going to type 9, and then sine, which is right here. Got sine, cosine, and tangent all in a row. Sine of 21. And it's going to tell me that my answer is 3.225. I'm going to round to the nearest 2 decimal places, so 3.23. So AC equals 3.23. Now to find this side using sine, I'm going to need to know what this angle is. But fortunately, because this is a right triangle, I know this is 90 and this is 21. So 90 plus 21 is 111. 180 total minus the 111 we already know. That means that the remaining angle is a 69-degree angle. So this is 69 degrees. So I know that the sine of 69 degrees is equal to the length of the opposite side here. We'll call this y, because it's a different number from the x, over the length of the hypotenuse, which is still 9. And then I'm still going to multiply both sides by 9 to get my answer. So 9 sine 69 should give me my other one. 9 times the sine of 69 degrees is 8.40 to the nearest hundredth. So BC equals 8.40. Now let's move down to cosine. So first, find the cosine of A and the cosine of B. Remember, cosine is equal to the length of the adjacent side over the length of the hypotenuse. So for angle B, the adjacent side is 12, and for angle A, the adjacent side is 16. This is the side that it's next to, but that's not the hypotenuse, because both of them are next to two different sides. Just one of those is the hypotenuse, and one is called the adjacent side. So the cosine of A is adjacent over hypotenuse, and then we can simplify that to 4/5. And then the cosine of B is adjacent 12 over hypotenuse, still 20, and we can simplify that to 3/5. Now we can do the same thing that we did before, but with cosine, to find the lengths of missing sides if I know one side and one angle. So to find AB, which is x, and we'll call BC y. So to find x, I know that the cosine of this angle, which I need to find, so I know 90 degrees from my right angle plus 37 degrees, and then 180 minus that leaves me with 53 degrees for my remaining angle. 53 degrees. So the cosine of that 53 degrees is equal to the length of the adjacent side, which is x, over the hypotenuse, which is 13. And since I'm dividing by 13, I'm going to multiply by 13 to get rid of it on both sides. And so AB is going to be 13 times the cosine of 53. 13 cosine 53. So that's 7.82. Now to find y, I'm going to use the cosine of 37 degrees, which equals the length of this side, y, over the hypotenuse, still 13. And again, multiplying both sides by that 13 to get my answer. So 13 cosine 37 is going to get me BC. 13 cosine 37. 10.38. And that is the length of this other side. All right, now let's look at tangent. Remember, tangent is the length of the opposite side over the length of the adjacent side, opposite over adjacent. The tangent of A would be the opposite side to A, which is 15, over the adjacent side that's not the hypotenuse, which is 20. 15 over 20, which is 3/4. And then the tangent of B would be the opposite side to B, which is 20, over the adjacent side to B that's not the hypotenuse, which is 15, which simplifies to 4/3. And you'll notice that the tangent of the two angles that are not the right angle are inverses of each other, and that is always the case. All right, now let's find AB. We won't worry about AC in this case. So to find AB, which is this side right here, I need to do the tangent of 50 degrees, because I don't know the hypotenuse, I'm going to use tangent. And that's going to get me equal to the length of the opposite side over the length of the adjacent side. And then because this is x divided by 20, I can multiply by 20 on both sides. 20 tangent 50 for my answer. 20 tangent 50. And that gets me 23.84. This 5 rounds the 3 up to 4. So the length of AB equals 23.84. Now, an important thing to mention about sine, cosine, and tangent is that sometimes you will have different options for which one you can use. Sometimes you can choose whether you want to use sine or tangent, for example, or whatever. But sometimes the one you're going to use is dictated by the information that you have. So in this case, for example, I knew the hypotenuse and I wanted to find the opposite side. We're going to ignore this for a second. So I wanted to find the opposite side and I know the hypotenuse. So I want opposite, I know hypotenuse. Opposite and hypotenuse, that means I'm using sine. So if the sides that you are looking for and that you know are adjacent in hypotenuse, then you're going to use cosine. And if the sides that you're looking for / know are opposite and adjacent, then you're going to use tangent. So look at the side that you know and the side that you're looking for, and those combined are going to tell you which one of these ones you want to use. Okay, now we're going to move on to this paper. For this one, you're going to ultimately cut across here and then cut this box out and cut these flaps to glue down into your notebook. It's going to look like this. So you have this glued down here, and then you can open these flaps, and then this glued down underneath. So this is just for reference to remind you things that we've already written down. Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. And tangent equals opposite over adjacent. This is SOHCAHTOA. Now, a few definitions. Remember that opposite equals the side that is opposite the given angle. The hypotenuse is, or HYP rather, is the hypotenuse, which is the side that's across from the 90-degree angle, also the longest side. And adjacent means adjacent to, which is another word for next to, or touching the given angle. Trig ratios are a function made from the sides of a right triangle based on a given angle. So the sine of A here would be opposite over hypotenuse, which is 12 over 13. The cosine of A is adjacent over hypotenuse, which is 5 over 13. Tangent is opposite over adjacent, which is 12 over 5. And then sine of b, again, opposite over hypotenuse, which is for b, 5 over 13. Cosine is adjacent over hypotenuse, which for b is 12 over 13. And tangent is still opposite over adjacent, but for b, that would be 5 over 12. So notice that the sine of one angle of the triangle is the same as the cosine of the other angle of the triangle when we're not talking about the right angle. And the cosine of the one angle is the sine of the other angle. And then the tangents are inverses of each other, so they're just flipped upside down. So let's write the trig ratios for angle x and angle y. The sine of x, opposite over hypotenuse, 4/5. Cosine of x, adjacent over hypotenuse, 3/5. Tangent of x, opposite over adjacent, 4/3. And I'm not even going to look at this. If the sine of x is 4/5, then that means the cosine of y is 4/5. If the cosine of x is 3/5, that means the sine of y is 3/5. And if the tangent of x is 4/3, that means the tangent of y is 3/4. Okay, now turn the page in your notebook, and we're going to write some more. We're going to call this page inverse trig ratios. So we use an inverse ratio when you know the two side lengths and need to find the angle. So when we know both sides and we need to find the angle, we're going to use an inverse trig ratio. I'm going to draw some lines here to separate where I'm going to be working. Okay, so let's talk about first inverse sine. And in the calculator, you'll see this in blue above the sine function. It says sine to the -1. That's the inverse sine. Above the cosine, inverse cosine, cosine -1. Above tangent, inverse tangent, tangent -1. So that's where you find them. So let's say I have a right triangle. And I'm looking for this angle. It's x degrees. I know that this side is 24 and this side is 29. So I know that the sine of whatever x degrees is equal to the length of the opposite side, which is 24, over the length of the hypotenuse, which is 29. So I know the sine of x is 24 over 29, but what if I want to know what x is? Well, I'm going to take the inverse sine of both sides. Sine -1, take the inverse sine here, sine -1, and that's going to cancel out the signs, like the inverse operation. So just like division cancels multiplication and subtraction cancels addition, inverse sine cancels sine, and we end up with just x. So in the calculator, I'm going to put blue button sine to get sine -1 of 24 divided by 29, close parentheses, and it's going to tell me that my angle measure is 55.85 degrees. So x degrees equals the inverse sine of 24 over 29, which the calculator told me was 55.85 degrees. Another right triangle. My angle that I'm looking for is here, and I know that this side has a length of 9 and this side has a length of 20. So this angle, or this side is adjacent to my angle, and there's the hypotenuse, of course. So I know that the cosine of whatever x degrees is equal to the length of the opposite side, sorry, the adjacent side, the length of the adjacent side over the hypotenuse. And then I'm going to do the inverse cosine, cosine minus 1, cosine minus 1 on both sides. So x is going to equal the inverse cosine of 9 over 20. Blue button, cosine, 9 divided by 20, close parentheses, 63.25, and then the 6, so it rounds up, 63.26 degrees. So x equals 63.26 degrees. Okay, one more right triangle. I'm looking for this angle right here, and I know that this side is 17 and this side is 11. And this should be labeled cosine, inverse cosine right here. Now here, in case you're not sure, now here it's important to remember they won't necessarily tell you which ratio you're using. So you need to look at this and say, okay, I'm looking for this angle. I know the opposite side and the adjacent side. That's TOA, that's TOA, tangent. So this is inverse tangent. So the tangent of x degrees is equal to the opposite length, 17, over the adjacent length, 11. And then I'm going to do inverse tangent on both sides. Inverse tangent, inverse tangent. So x equals the inverse tangent of 17 over 11. Blue button, tangent, 17 divided by 11, close parentheses, 57.09 degrees. X equals 57.09 degrees.